Okay, next problem. I want to notice that I do have a polynomial over a polynomial. The degree of the numerator is less than the degree of the denominator, so I'm ready for fraction decomposition. I cannot factor x squared plus 9 any further in the real number system, so that means that 10 over x minus 1 times x squared plus 9 must be equal to some addition of two rational functions, one with denominator x minus 1, one with denominator x squared plus 9. For linear denominators, they only need a lesser degree polynomial, so I will put constant a. For a second degree polynomial that I am not able to factor into the real number system, I'm stuck with lesser degree as a linear, some unknown b, and then x plus unknown c. I need to find a, b, and c, and then begin the integration process. I'm going to multiply both sides by the denominator. The left side will turn into a 10. On the right, a needs to be multiplied by x squared plus 9. And then bx plus c, with a parentheses around it, must be multiplied by x minus 1. Now, I can plug in any zeros. X equals 1 is a 0 of the original denominator. When I plug it in, I get 10 equals a times 10 plus 0. So a is equal to 1. Now, I have a couple of options at this point, but I'm going to plug in two more values of x to find the other two constants. And plugging in 0 is going to be extremely convenient, as you're about to see. Plugging in x equals 0, I get 10 equals 9a plus, and then when I'm looking at my bx plus c, my b is being multiplied by 0. I have only the c, and then 0 minus 1 is negative 1. I know that a is equal to 1, so 10 must be equal to 9 times 1 minus c. And I can see that c needs to be negative 1 to subtract from 9 to make 10. And once I have 2 out of 3, then the third one is just about ready to be found. I can choose any number to plug in for x. I'm going to use negative 1 because it's nice with calculations. Going back to the equation, 10 equals, plugging in negative 1, I'm going to get 9 plus 1, 10a, plus parentheses, b times negative 1 plus c multiplied by negative 2. I know that my a is equal to 1, so I have 10 equals 10 plus negative b plus negative 1 times negative 2. I subtract 10, I get 0 equals, and I'm going to write this as b plus 1 times positive 2, and then I can quickly see with 0 being over here that b must equal negative 1 to make that equal to 0. I have my a, b, and my c. Now it is time to move to integration. Moving over to integration, this entire integrand is rewritten in this format, where a is 1, b and c are both negative 1, so maybe what I'll do is just go minus and then do x plus 1 instead of negative x minus 1. And this is now what I have to work with. For the first term, the integration is going to be nice. A quick u substitution of x minus 1, and the integral is the natural log of the absolute value of u. Put the u back in. And because the derivative of x minus 1 is 1, I don't need to bring in any extra constant multiples from the u substitution. Now, to integrate the second term, I can either go straight to trig substitution and do more trig substitution than I need to do, or I can split the numerator so that I can do some of that trig substitution as a u substitution, which is always easier. The u substitution is always going to be easier if it's available. Now, when I choose how to split that numerator, I should be thinking about, if I do a u substitution of x squared plus 9, what is the derivative? It is 2x. Now, I want you to notice that with u being x squared plus a constant, I do not have a plus, shall we say, b times x. I do not have an x term, which means I'm not going to have a 2x plus a number or minus a number, which means that I can literally split the numerator as I see it. I don't have to figure out what constant to add to the x with a leftover bit. Now I'm going to integrate x over x squared plus 9 plus 1 over x squared plus 9. And I'm going to go back to the fact that I started off with, I've got the natural log of absolute x minus 1 minus, and now if I do a u substitution, I get an extra 1/2 due to my u substitution. The rest of it is integrate 1 over u, natural log of absolute value of u, which is x squared plus 9. X squared plus 9 is positive at all times, so I don't need the absolute value if I don't want to put it down. Then this plus sign. When I go to integrate 1 over x squared plus 9, that I need to use trig substitution for. However, maybe you have memorized a formula and you want to spit it out, but where does that formula come from? When I have addition of my function being squared and my number being squared, I use tangent. And I set it equal to the function that is being squared divided by the number that is being squared. I'm going to set up my right triangle, opposite over adjacent because it's tangent. Pythagorean theorem gives me the square root of x squared plus 3 squared. Now, once I choose my u for my trig sub, I need my du, so I need to take the derivative. Derivative of tangent is secant squared. Derivative of x over 3 is 1/3. And I can save myself a little bit of time if I look at which trig function gives me the ratio of the answer to Pythagorean theorem divided by the side that has just the constant. So the side that has the answer to Pythagorean theorem is the hypotenuse. The side that has the constant is the adjacent. Hypotenuse divided by adjacent is cosine's reciprocal, secant. Now, as I substitute in, I need to substitute for my dx, and I can substitute for my x squared plus 9. X squared plus 9 is equal to squaring 3 times secant theta. My dx is equal to 3 times secant squared theta. So that means I am getting the integral of dx divided by just this x squared plus 9, which is equal to 9 secant squared theta. This then reduces to the integral of 1/3 d theta, which is 1/3 times theta. I go to my original u substitution. Theta is equal to the inverse tangent of x over 3. So I'm getting 1/3 multiplied by the inverse tangent of x over 3. And then plus c. I can simplify a little bit. First, I need to distribute my subtraction. I don't need the absolute values. Subtraction. And I can simplify with log rules. I can take the multiplication by 1/2 and turn it into an exponent. So this is now the natural log of x squared plus 9 to the 1/2 power, meaning square root. And then when I subtract the two logarithms, I divide the insides. Only the x minus 1 needs that absolute value. And if you heard the get to class bell, you know that it is the end of lunchtime. Goodbye, and fortunately for this video, we did not have to listen to a live band.